Assalamu alaikum, my dear students. I hope all of you are fine. So there is another video upon your request, and now I'm going to start the topic that is magnetic field, and these questions are from 06 to 5 board, and this question is from 2015. A physics teacher suspends two pointers in a magnetic field. One pointer is made of brass and the other is a magnet. Here you will see this is the brass pointer, like this one. And here we have a magnet, north and south pole. She holds the pointers in initial positions shown the two upper circles of figure 7.1. She then releases the pointers. Like initially, she will hold here in this position, these two pointers, and then she releases it. They are saying in the lower circles, like these two circles, draw the settled final positions of the two pointers, right? So here we are going to draw them up. First of all, did you notice that here they mentioned that arrows shows the direction of a strong magnetic field? Like these are the arrows which they are talking about. And they are representing the very strong magnetic field here. So it means that we have here the north pole of this magnetic field, and here we have the south pole of this magnetic field, right? So now we should start drawing the new positions or the final positions of these pointers. First of all, I'm going to draw the brass pointer. As you know that brass is not a ferromagnetic material, so there will be no effect of the magnetic field on it. So there will be no change in the position of the brass pointer. So we should draw the same position. Like here it is horizontal, so we should draw the horizontal brass pointer once again. Uh, Here, now we are going to draw the second diagram, that is a magnet. And as you know that magnet will be affected by this magnetic field, so the new position of it will be like this. Like you can say that north pole of the magnet will be towards the south pole of the magnetic field, and south pole of the magnet should be towards the north pole of this strong magnetic field, right? So you can say that this magnet will align itself according to the magnetic field, like north pole of the magnet should point toward the south pole of the strong magnetic field. Okay, so here I have explained even they are saying that you will explain the final position of the brass pointer. So you can say that there will be no force which will act on it because it is not a ferromagnetic material. So magnetic field will not apply any type of force on it. So there will be no force. Okay. And if you have to write here that what is the final position of the magnet, so you can write that the magnet will align itself according to the magnetic field. Like north will point toward the south pole of the magnetic field, and south pole of the magnet should point toward the north pole of the magnetic field, right? So this question is of 2 marks, 1 mark for writing here and another mark for writing the answer here. Suggest a material from which the magnet is made. The magnet should be made from the hard magnetic material, and the hard magnetic material is steel. All right. So steel, you have to write here that steel will be the hard magnetic material, and we are going to write steel as an example. You can also write cobalt and nickel here. In the marking scheme, even they mentioned ferrite as well as cobalt and nickel along with it, but they mentioned that they should not be iron because iron is a soft magnetic material, so we should not write iron here because iron is used to make the temporary magnets only. Here is the next question. A permanent magnet is made from one material. Underline the material from which it is made and from which it is possible to make the permanent magnet. As I told you previously, that which material should be used to make the permanent magnet, and that is steel here, not the iron. So steel will be the best answer for this part of the question, right? In the next part of the question, they are saying that an electron source produces a narrow beam of electrons that travel at the same speed. The electron source is placed in a vacuum and the beam of electrons travel vertically downwards. Like here, this is the motion of the electron beam. This figure shows the beam of electrons before it passes between the N pole and S pole of the magnet. Describe what is meant by the direction of magnetic field and state the direction of the magnetic field. This question is of 1 mark only, and you have to explain only the direction of magnetic field. So in this question, you have to explain the magnetic field here. So the answer for this will be that the direction of the force on N pole should be there, and it means that it will be from left towards the right side. This is the magnetic field. You know that it is always from the north pole it will start and it will end towards south pole. So arrow's direction is important here. Like you should know and recall it, like you should know that from it should be from north pole towards the south pole of the magnet. Okay, so the next part is next question we are going to do. I'm not going to solve this question right now because it's from your next topic, that is 4.5. So now moving toward the next part. This figure shows a bar magnet and 4 plotting compasses A, B, C, and D. Here, the question is that draw an arrow on each of the 3 plotting compasses B, C, D. Like here B, C, and D, we need to plot the compasses just like this. And to show the direction of magnetic field and label the magnetic poles of the bar magnet N and S. As you see that here, the arrow is pointing outwards. So this pole is north pole. And you should know it very clearly that when we are drawing the magnetic field lines, so the arrows should be pointing outward from the North Pole and towards the South Pole. If this is the North Pole here, it will be the South Pole. And you know that this field will be like this, okay, passing through it and entering in it. And similarly, from the other side, if you will take field like this, so pointing toward the South Pole. So if you will see from here, uh, in the D side, the arrow's direction will be like this, and it will be entering towards the South Pole. Let me erase these now. So you will see that how it looks like. So these arrows should be pointing in these directions, all right? Moving toward the next part. Describe one method for demagnetizing a bar magnet. So you should know there are different methods of demagnetization. You can demagnetize it by the help of like heating is also one of the process at very high temperature. You can even hammer the magnet repeatedly and not in the presence of magnetic field, because if it is in the presence of magnetic field, then it will be magnetized, the bar will be magnetized. But to demagnetize it, we should hammer it in the absence of magnetic field. This part is also not a part of your assessment syllabus. Moving toward the next part, that is, this figure shows 2 magnets and the gap between the N pole of one magnet and S pole of the other magnet. On figure, draw 3 lines to show the pattern and direction of the magnetic field in the gap. Once again, you notice here that they want that you will draw the magnetic field lines. So please do remember this thing while drawing the magnetic field lines, that it should always starting from North Pole and pointing towards the South Pole of the magnet. At least 3 of them are needed. So here we have a draw here, and 1 mark is for the correct position of the arrow. The next part is that this figure is a repeat of figure 7.1 showing the 2 magnets here. On figure, draw the position of the plotting compass needle when it comes to rest in the gap between the N and S pole. So the plotting compass needle will be like this. You know that the arrowhead of the plotting compass, let's suppose this is the compass. The arrowhead of the compass is representing the North Pole and its tail is representing the South Pole of a magnet. So of this compass. So please make sure that when you are going to plot it, the North Pole, like the arrowhead, should be pointing toward the South Pole of the magnetic field, whatever is the provided to you in the question. So here in this case, we should point this toward this magnet. Okay, arrow should be pointing toward the South Pole of this magnet. Moving on toward the next part, explain why the needle comes to rest in this position. Like if this is the question, here they are saying that why this needle is in the rest position. Because this compass needle will align itself along with the field, and north pole of this compass needle is pointing toward the south pole of the magnet, right? So this thing you have to write as I have already explained to you. Describe a method of demagnetizing a bar magnet. Once again, this is the question, and you will write, you can heat the magnet to a very high temperature, so you will be able to gain the mark. The next question, it's from 2022. This question is about the magnetic fields around a bar magnet. This figure shows two positions used by a student doing an experiment. Position 1 is given to you and position 2 is given to you. The second figure shows a magnet labeled magnet 1 placed on position 1. On figure this 7.2, you need to draw the lines to show the pattern of a magnetic field around produced by a magnet 1 and place arrows on the lines to show the direction of this field, right? If you are going to draw the magnetic field line because of the position 1, one thing which is very important, one complete loop above magnet and one complete loop below magnet is very important. You know what is the pattern of the magnetic field of the bar magnet? It's just like that. Okay, you have to draw these loops and these are the lines like this. Make sure that these lines should not touch each other because it is very important. Otherwise, they will cut your 1 mark because this is they are normally writing this thing as well in some of the questions that these field lines should not touch each other. So these are the field lines of a bar magnet around it. 1 mark for pointing the correct position of the arrow and some of the marks, one of the mark is definitely about its correct, you can say, diagram. Okay, 2 correct arrows are needed. Additional field lines are also needed, like this here I have drawn some of them. So 3 marks are completed. Then they are saying that magnet 1 is removed from position 1 and this figure 7.3 shows another magnet labeled magnet 2 placed on position 2. So on this figure now 7.3, at right hand end of position 1, a line with an arrow to show the direction of magnetic field produced by magnet 2. So you should draw the line like this representing its magnetic field. So this line should be towards the left side and arrow is also needed here, which is representing the direction of the magnetic field because you know always it will be from north towards south pole. It is coming out from the north pole, so you can draw like that. This figure shows magnet 1 placed on position 1 and magnet 2 on position 2. State the direction of force that the n pole of magnet 2 exerts on the n pole of magnet 1. This is the magnet 2. So it is going to apply a force on magnet 1. So its direction will be towards the side because this magnet is applying force on it. So arrow should also be pointing toward the magnet 1 or towards the left side. It should be away from magnet 2. Or you can write here that it should be like I draw it here but you have to state it at this point, right? Like force to the left or away from the, or force should be away from magnet 2. You need to specify the which magnet you are talking about, because here there are two magnets, so please mention the magnet, that which magnet they are talking about. Um, so the next part is that we have to justify our answer even. So force should be force on north pole of the magnet, that is in the direction of the magnetic field. All right. So these are the questions till 2022. And now I'm going to solve from this is from the latest paper question. This is from summer 24 P42. And this question says that this figure shows 3 bars of steel A, B, and C. Like these are made up of steel A, B, and C. A student is given the 3 pieces of steel. 2 of the pieces are magnetized and 1 piece is unmagnetized. Okay, like you can say out of these 3, 2 of them, let's suppose, are magnetized, because they mentioned here 2 pieces are magnetized and 1 of them is unmagnetized. But they are saying that you have to describe and explain how the student determines which piece is unmagnetized using only the 3 pieces of steel. Okay, so this question is of 4 marks, and we have to tell them that how we can tell them that which of the 2 are magnets and which of them is unmagnetized. We need to figure out the unmagnetized rod by explaining them that how these are. So you can say that you can take 1 piece of steel and or one piece of steel you can take, and you can draw it closer to another piece. You can then see that if there is a repulsion or attraction, you can test between the different ends or different poles. Like from both the ends, you have to bring it closer. Like for example, I'm taking A, and this is its first side and second side. Let's suppose I'm testing this with the help of B. So once you can check that whether it is attracting or repelling each other, and then later on you can switch its place, like second position here and first here, and then check once again. So if there is keep on attraction like from both the sides, then you can say that this steel A, which is the first bar, that is unmagnetized because it is keep on attracting. There is no repulsion here, right? So you can repeat this test between the other pieces as well. So only you know that magnets will repel each other. So attraction at both end indicates one of them is unmagnetized. So like this, we can explain all of our parts and we are able to gain the 4 marks. There is another question that is from winter 2024 P41 from this topic, magnetic field. Here, a solid bar is inside a copper solenoid. This figure shows the copper solenoid is connected in series with a battery and a variable resistor. So the device shown in figure is an electromagnet. They are saying that what is the suitable material for the bar. If it is an electromagnet, a temporary magnetic material is needed, soft magnetic material is needed, and that is iron. Right? Soft iron you can write, or a simply iron you can write. Here you will be able to gain this mark. The right hand end of the bar is S pole. Like this is the south pole and this is the north pole of it. This figure shows the bar viewed from above. On figure 7.2, this is the figure 7.2. You can draw at least 6 field lines to show the pattern and direction of the magnetic field surrounding a bar. So again, those points should be kept in mind while drawing them up, that at least one loop up, one loop down, and few lines like that, okay, coming out of it. So actually you need to um, make the exact field pattern of the bar magnet. So it is entering in the south pole but coming out of the north pole. So I'm going to draw here once again, pointing toward the south pole, coming out of the north pole. This is the north pole of the magnet. So in this way, at least 6 of them are needed. So this is the exact pattern which we are able to draw them up, and we will be, inshallah, be able to gain the maximum marks in it. Okay, so one complete field line between the poles, no crossing, and the shape should be correct, and at least 6 field lines are needed in it. And one more thing, that these arrows are also important. In the previous question, you noticed that they are saying at least 2 correct arrows should be needed. So please make sure that whenever you are drawing the magnetic field lines, try to draw the arrows on each and every field line, but minimum of them should be 2 in number. All right. The resistance of the variable resistor increases. Explain what happens to the magnetic field surrounding the bar, and state how the pattern of field lines that represents the field changes. One which is very important thing here is that current is directly proportional to the magnetic field. More current, more magnetic field lines. More magnetic field line means that the field lines are closer to each other. If the value of current is very less, it means that the magnetic field is weaker and the field lines are further apart from each other. So as here the resistance increases, then it means that the value of current decreases in it. So if the value of current decreases, then the strength decreases and field lines are further apart from each other, right? So you can write this, that current decreases in it, current decreases, right? And the strength of the magnetic field decreases, like magnetic field strength decreases, and the field lines, magnetic field lines, are further apart from each other, from each other. So till here our questions are finished. I hope that after watching this video, you are able to understand the topic and you are able to gain good marks in your upcoming exams. Take care then. Allah Hafiz.